In internal combustion engines, the power of the exploding fuel has always been transferred to the wheels of a motor vehicle via pistons, connecting rods, crankshafts, and gears. The piston connecting rod crankshaft unit is a weak point of the internal combustion engine, as the acceleration forces acting there at high speeds can lead to, for example, the yield strength of the connecting rod material being exceeded, which leads to its destruction. The crankshaft of an internal combustion engine must therefore not exceed a maximum speed specified by the manufacturer. Felix Wankel wanted to overcome this limitation with his Wankel engine. His engine operated with a rotating piston, making connecting rods, crankshafts, and camshafts unnecessary. Unfortunately, this engine design suffered from long-standing problems with the seals, which prevented it from gaining widespread acceptance. Furthermore, the trochoidal combustion chamber shape does not allow for high compression, resulting in poor efficiency and consequently high fuel consumption. The spherical motor invented by Swiss inventor Arnold Wagner demonstrates that it can be done much more simply and reliably. The principle of the spherical motor was first conceived by Frank Berry in the USA, who invented and patented such a motor in 1961. Unfortunately, the inventor died in 1969, which is why his idea was forgotten. The Swiss inventor and aircraft manufacturer Arnold Wagner revived this idea and successfully developed it further. This stroke of genius was put into operation for the first time on December 31, 2004 at 2:15 p.m. Arnold Wagner later installed his spherical engine in a Yamaha YP400 scooter to test its suitability for everyday use. Although his water-cooled Haiteng spherical motor works partly on the principle of the Berry motor or the Hutland spherical motor, it is largely his own development, protected by numerous patents. Ceramic balls are crucial components that ensure the ball motor functions. A positive control mechanism is achieved via the rotating pivot axis, which supplies the air-fuel mixture and expels the exhaust gases. Connecting rods, crankshaft, and camshaft are therefore unnecessary in a spherical engine, and where parts are eliminated, the weight of a motor is naturally correspondingly lower. A spherical motor with 26 kilowatts of power weighs just under 23.5 kilograms. The operating principle of the spherical engine is relatively simple. The left, funnel-shaped opening is a recess for the rotary pivot axis in the spherical piston, with the rotary valves on this rear side of the piston controlling the intake of the mixture enriched by the injection system and its further transport through the transfer ports into the working chambers on the front side of the piston. During the continued movement, the merging halves of the spherical pistons compress the mixture. The mixture is ignited by the spark plugs, causing the pistons to be forced apart. Unfortunately, political decisions prevented the spherical engine from gaining market traction. As a hybrid drive for the cabin motorcycles also built by Wagner, the spherical engine would have been quite successful, as this drive unit, according to its inventor, would have consumed only around 2 liters of fuel per 100 kilometers with a power output of 60 kilowatts. But Arnold Wagner was not discouraged by this setback. Instead, he ensured that cabin motorcycles, fully electric and therefore perfectly in tune with the times, are built in the Czech Republic under the brand name Monoracer. Companies wishing to manufacture the spherical motor outside of Europe can acquire a license. Paravi's contact information can be found in the accompanying text to this video.